Again, this is Old Man PHP. I create PHP video tutorials for the old guys who want to learn a new skill and compete with the young crowd. This is video 115M, and as you can see from the title, full big old notation explained. This is the data structure that I wanted to, no, that's not it, that we talked about, right? Now I want to break it down to the actual data structure, which would be this one. This is the algorithm. Well, we're going to talk about that in a second. And this is, well, guys, I do have my cup of coffee here, and I don't know if you're supposed to be doing this coffee thing, but I actually caught the bug. My wife was sick all week, for 2 weeks actually, with the flu and everything, and now I got it. But I still wanted to do this video because I always liked it, this one. So please bear with me. So again, data structures are like specialized formats for organizing, right? We talked about that: processing, retrieving, storing data, such as arrays. Remember, we talked about the linked list, the stacks, the trees. Algorithms are step-by-step procedures, right? Or formulas for solving a problem, right? You always hear it, oh, algorithm, because the pieces of algorithm for the whole programming. I mean, the whole thing for me is an algorithm, to tell the truth. But there's always little pieces that need special treatment. Especially when you want to concentrate on sorting, bubble sorting, or whatever it is that you really need as repetitive. I'm sorry, guys, man. And like sorting, searching, and the likes, right? And so I'll show you this little picture I created. So you start here, right? You input your stuff. You got your first process. Then you have your decisions, right? That's the if statements, and then you go. If it's a yes, you go this one. If it's a no, you go this one. If it's a no, then you have your own process to deal with that. Then another one to go with it. Then that's the end. And this is the same way. I hope you like the pictures. And together they are like the fundamental computer science for writing efficient programs. So if for an example, let's do a little thing here. Let's go down. Let's do this. I want to do. Let's come up with this. I mean, I think I did this before in some other stuff, but let's do this. Let's say 85. And then you want to do an if, right? What is it? Dollar score is what is it? Greater or equal to, let's say, 90. I like to do little spaces here so you kind of see it, you know. And then you go like this, you open it up, and then you say, well, if it's greater than 90 or equal to 90, right? What does he get? What does a person get when they're in school? They get an A. So you could say grade. What would be the grade? A. But what happens if it ain't that? Let's say if it's, how about more than 80? So we could say else, right? We say else if, and then go like this and say dollar score is it greater or equal to 80. Let's put a little space there. And then you do another branch. And then you say, oh, okay, let me echo. I'm pretty sure this will work because it's kind of simple. And then over here, we're going to say, well, else, oops. Now this else belongs to this one right here. This right here. Not this one. Because it already has its own little. And then we could say echo, what would be the C. That was a C and B, and I also did get A's. I'm not gonna lie to you, but I was mostly B's. Sometimes life, you know. I did score 140 in my IQ way back when I was an adult, not as a kid. Okay, so then, I'm so sorry. How about we save this? Right? Let's see if we can make this to work. Right now, this whole thing is a PHP, so I don't really need to put this in the function or nothing. I'm just like running it straight. I saved it already, so let's go here. Look, I was practicing earlier. This is grade B. See? Because he's an 85. If he did something like, I don't know. Let's do, what is a C? A 70 or 75? I mean, I don't know. Let's see. C or lower. Oh man, that sucks. Okay, how about if we make this a 75? This still be a C and lower. Okay. But anyway, so this code, right? This snippet right here is considered a. This is. How about we go like this? This. I'm not gonna write a lot because I'm gonna have it all done. Remember I told you I record these things. It's considered a old one constant complexity, right? So the explanation is that the old one, right, is like the big notation. It's like the best one. Where do I have it here still? It's the best one. It's the best one. And remember when we talked about the decision making? Not that one right here. Flow. If you go one way, you go another way, right? That would be this right here. I'm so sorry. Maybe I should have done this video, but I'm gonna keep going. Because, I mean, it's long, but not that crazy, right? So in your code, the operation performed. What is it? It's a series of simple comparison, right? Which what this was right here. Simple, right? We use the greater and equal sign, which is what this is, right? And then the output, we're using the echo, right? Because you've seen the echo before, right? Now, these operations take the same amount of time to execute, whether the input value score is 50, 95, or any other number. So the code doesn't loop over the input. It recursively calls itself or performs any operation whose time complexity depends on the size of the input collection, which would, be that. So that's the one. So it only execute one of the comparison block, right? Based on the single variable value, and since the number of steps comparison output is fixed, meaning that you did 75, it just does one fix. It checks one time. No, okay, then don't do this. Then give me this, or do this. Look, check for this. No, give me this, or give me this. It's just a quick thing. That's all it is. So it's fixed and it does not change with the input value, right? No matter how many times you run it. So the complexity is all one. All one right here. So the big old notation is like a mathematical notation. I think I mentioned that before. That describes the limiting behavior of a function. Remember when we created the function? When the argument tends toward a particular value or infinity, right? If it was like I'll explain that in a bit. And in the computer science, it is used to, like classify algorithms according to how they're running time or space requirement. And it grows. Again, I do. Once it starts to grow, depending on what it is, that's when you start using the different ones, right? But right now, this here, so when you're talking to somebody, you say, oh, it's all run. Now, the constant time, right? That's the time taken that is fixed and doesn't change as the input size grow, right? Because it means that the operation is independent of the end. Now, an example of an operation like this, remember we talked about 5 milliseconds again, array, and 5 milliseconds for, let's say, the 1 billion. I think we talked about that in the last video, or maybe the one before that one. I can't remember. It is the time complexity of O1. The 1 in that O1 represents the constant value. The actual number of steps might be like 1, 5, 100, 150, or any other fixed number. But since the big O notation focuses on the rate of growth, as the end approach infinity, all constants are simplified to, you just write 1. That would be the thing. So O1 operation PHP, that's it. This is an O1 operation PHP. Now many fundamental operations in PHP and other languages are O1 also. Just because the language is a little different, but the approach is the same thing. So if you're accessing an array element like by index, like if you did something like this, oh my god, I can't believe it. I gotta get VIX. If you did this, right, that's accessing the 6th element. That's constant time, regardless of the size, and that will be an O1. Maybe I should do this. That will be an O. What's going on? Oh, that will be an O1. So when you're accessing an object property, right, when you do this, like, I think I did something like this before. Maybe not. It was just something different, but I'm just going to use what I'm going to use. And that would be like this. Remember how you do the property? Remember the property? How do you spell that? Property. Remember? This is an object. You use the new to create an object from a class. That's like a blueprint. Remember we talked about that? Then you're going to use the property, whatever it is that you're using from that class. And that would become an O1. And basic arithmetic too. Let me get rid of this. Like basic arithmetics, like addition, subtraction, multiplication. That's also will be considered a 1. But something like this is simple, say quick, right? It will be B plus C, like that. That will be an O1. What do we just? Or if you, oh man, I'm sorry guys. Now if you're checking the size of the PHP array, like using the count, remember the count that we kind of did that? The count, right? That's cool. That will be also one. Now a crucial note internally, like the PHP arrays, because a lot of these things they use the array. It's just the way you approach to get that stuff from the array is what gives you the different calculations right here. So when you're using an array, right, that often stores the size as a property. So retrieving the size is usually a quick O1, which is count, right? This right here, count. Let's move this down. All right. Let's save this. And then, what also, so if you do like I don't know, like the count like this, and within there, this array, that will give you the count of the array, right? That will give you a count of the array. That's fast. This is a fast lookup. And that will be an O1. Let's say like this. would be an O1. Now adding and removing an element at the end, or yeah, like the push and the pop. Remember that one? PHP. That's also an O1. So like if you can, let's get rid of this. We'll do this. Let's do this. How about we do like this? We're not gonna use. No, we'll use letters and stuff. I don't feel like dealing with adding. What is it called? Double quotes and stuff. I just don't feel like. I'm just gonna use numbers. Right? Zing, zing, zing. Again, how we do that? We say echo. We're gonna do the pre. What is it? Like that. Okay. And this would be print R, which would be dollar array. Let's close it out. Let's do this. There you go. 1, 2, 3, 4, 5. See the index? 0, 1, 2. This is considered O1 when you have to look for something real quick. This is on O1. If you do like echo, like array underscore pop, what is it? Papa. Oh, Papa. Let's see. On. Pop. Array. See? And what this does is it removes the last element, right? So if I kind of went like this, print R dollar array. This is typically an O1 because no other element needs to be shifted, right? So the O1 is the fastest possible time complexity and is highly desirable for critical operations. So let's see if we can get this to work. How about we put there you go. There you go. 10. Remember how we took out that one? Because it takes it from the top. When you say pop, it takes it from this right here. It took the 10. That's what that is. Why is that? If I run it again, it's going to take the 9. There you go. Don't hold that. Still that guy. And what? I did pre. Pop the 10. That's what that is. We pop the echo. There you go. So much easier. See? 9 and it popped it. It popped it, gave you the 10, and then gave you what it looks like now. And that's the fastest time. Now, constant time complexity that denotes an O1 means that the algorithm right? Uh, let's see. Let's go here. The algorithm times, right? It's doesn't depend on the size of the input, the data set. So no matter how large the input is, like the number of operation algorithm performs the same thing. So this could be like, let's say 1,000, whatever. It still be fast. It still be 01 because you're just popping it, right? So the fixed execution time, the time taken. Listen, all the stuff that I'm saying, it'll be on the actual description on a file, text file. That's significant. That the what is it that? Oh my God, I can't breathe. That. So, for example, if it might take 5 steps, whether the input has 1 item or 1,000,000, and depending on the input, right, that one signifies a fixed value. Not necessarily one single operation, but rather a number of operations that does not change the input size. So the efficiency, this is like the most efficient type of time complexity as its performance scale perfectly. Then a common example of one operation is like accessing the input, which we're doing right here, right? Uh, by the index. And then you got your array 1, you got your single computer can calculate the memory address of the whatever's in here, right? And oh my God, I can't breathe. Oh my God, I'm gonna have to cut this. So the basic arithmetic and assignment, the simple operation like adding 2 numbers like these things here. Let me see. 5 plus 3. That's just Y. C. C, senor. That's an O1 operation because it's quick. O1. So when you're inserting, deleting input, like what we're going to talk about in a few seconds, the linked list, right? Usually when you have a pointer to the head of the linked list, which we're going to be talking, inserting a new node is at the beginning, while there's only a few pointer manipulation, which is a fixed number of steps. Now the changes to the new nodes, which is the next point. Remember how we have how you have to point to, you go to one next to it and it points to the one that pointer to the current head. I'm just trying to fix my scene here for a second. And that changes the list head pointer to the new node. And then you have your hash table, right? The hash table lookup, the average retrieving of value from a hash map. That's not an array really. That's an associated array. Or they call it a hash table too. By its key. So if you're doing that, that will be an O1 operation. It's just the same thing as doing like this. But instead, if we would have had a key, it would have like a name, right? I'm going to put just the word key. Like that. And that's an O1 operation. So that, because that computes the potential location or the bucket of the value. And in the worst case scenario, I think we talked about that is due to the collision. This can be degraded to an ON. Now you got your loop, right? When you do the loop, you remember the loops, the 4 loops. So if you go like $4, I, let's just say 0. Remember how we do it? You say I is less than 3, and then you want the $I to, what you call that, to increase by 1. That's how you do it. Why is it giving me all? Tell you what, let's get rid of that. So why is it doing that? So then you want to echo, right? Let's say we do an echo. And let's add 2 of them. And let's say you want to count, right? Like counting the $I. That executes 3 times. That executes 3 times. Let me see if it'll. No, let's see. I was gonna do something, but there you go. 0, 1, and 2. Execute 3 times. Yes, the code is considered an O1 constant time. O1 because it's fast. Now, why is it O1? Because the big O notation describes how the execution time of an algorithm grows as the input of n grows. So this becomes 10. The loop runs a fixed number of times. In this case, it was 3. Now I made it into a 10, which is independent of a variable input and the size of an n. So since the number of operators doesn't change regardless of how large the input could be, the algorithm is set to have constant time complexity of 1. And now, if n were used as a loop boundary, like this would be a linear time. It would be, if I change, how about if we copy this? What's that? Because I don't feel like doing anything with it. I'm going to say n like that. Or whatever thing you want to do here. And that n will be whatever the, oh, it can't be like this, it has to be this. Then that's the linear time of O n, because we don't know what n is. Because you're not going to know what n is. So maybe somewhere in the program you're going to assign something to the n. And that will become a O n. O n. So if you have a function that's called like this, let's say, I don't know. Oh, let me get a sip of this one for you. This coffee's got protein in it. Then you say function. Plus, I got a little slight, I don't know, that little base where the nose is, with the piece between the eyes. Man, I got a little pain there. And that would be $width. And let's say the height, right? We see stuff like, and then we say, hey, I want to return, right? Because you want to return what $width is, and $height. So then what you do is, now remember, when you create a function, it doesn't do anything until you call it, right? You have to invoke it. So let's say we're going to assign in an area, a variable called area, and we're going to say, hey, I want you to, let's do this. And then you say, I don't know, give me 5 and 10. That controls the jump to the function and returns, right? Because you go like this, it sends it goes up. So the area will always be, what is it? 50. You know what I'm talking about, right? I'll tell you what, I'll just write it up here. So we're going to say area, $area. Oops. That's crazy. Is this spelled right? I don't have any errors there, so let's see. This should be easy, of course. There you go, 50. Let's bring this up a bit. There you go, 50. Now the flow is like, check. in this particular case, we're only doing a simple thing, and in this case, you go into the loop, and in this case, you go to what is it? The if and else. When you do that, that checks the it and the if and else if, then executes for the loop 3 times, then calls the calculating area function and finally prints the results. That's if you was using if. Doesn't matter because I'm not doing it already. I'm just going through the loop. Now the O and the one like this is for, remember, it's like when you got a loop within the loop. So the outside loop goes to the thing, then it goes into that inside loop and it does this thing. Then it goes right back to the outside loop. It goes to the second thing. You get my man. You get what I mean, right? So you're gonna be O like this, n squared 2. And that this is like the time complexity often associated with the nested loop, like I just mentioned. Not only that PHP, but in other computer languages too, does the same thing. So it describes how the execution time of algorithms scales with the size of the input n. So understanding O n2, that's quadratic. They call it the quadratic time. That the O n2. I'm gonna try to see if I pronounce it right. It's actually big O n square. Big O n square. I know. And it's classified as efficient, man, especially if the time complexity. So what I mean by that is that the quadratic scaling that they do, right? The time required to run an algorithm is proportional to the square. So you know you got the loop within the loop, then that would be the n, right? And then if you double the input size, like the n2 square, the execution time will increase by a factor of 4. It will be something like, how would I do that? It would be something like, 2n square 2, which will equal to 4n square 2. Nope. 2. Be that. So why nested loop results in an O and 2 square 2? Because a nested loop, like I mentioned again, is a common structure that leads to complexity when the inner loop runs a full complement times for each iteration of the outer loop. Remember we talked about that. So consider that the oh man. So let's say we did a function check on the score, let's say pairs or anything. How about this? This remember, this is just a function. It does not do anything. Let's say that n equals to, let's say, count $list. Now what will be the list? And then you say within that function, you're gonna say, oh well, so this outer loop will run like number of times. We don't know, right? Until we find out what the list is. So we could say $, what is it? $I equals to 0, and then $I is less than $n, then $I number double. Let's make this like this. And then within that loop, of course, we're going to add another loop. So we're going to say for $j, I think we talked about this already. 0 equals to $J $N, and then you say $J plus plus. And then within there, you want to do, what you would call it, a branch, right? So we're going to say if $list is $I, like that. Then you're going to say 1, 2, 3, we're going to stick with this $list, $J. We're going to do that. $J, $list, $J, yes, yes, yes. Then we're going to go right here. We're going to say about $I is not equal to $J. Wait a minute. Then we go echo. Something like echo found a duplicate pair. But whatever. That's a big pair. It could be anything you want. So it would be. Remember, this is another way of writing out your array. $. Like that. Okay, let's see. Now we're gonna let me see. We don't know what this is, what N is. That's why you have this here. But by adding this stuff, remember we've done it before. We add something to this, and then it calculates, and that's what it becomes an O N squared of 2. And that in the list, it's kind of like right here. These are better. This is okay average, I guess, because it's what are you gonna do? It's a for loop. So what happens is you look at this stuff, you say, well, you know something, if we did it this way, it'll be an O N squared 2. Why don't we use something else, like the linked list, and that's how you get to that point when you go, okay. And then you calculate that, see what it is, and if it's all 1, perfect, then that's how you will go. Now this belongs to who? So this belongs to that guy. And then over here, let's do the list, right? Let's say list equals to, I'm not gonna go crazy. 1, 2, 3, 4, and 5, 5. And the reason I did that is because I'm gonna check for duplicates, which can why I wrote that there. And then we're gonna say check underscore pairs. It'll work. Let's see. See, this is just creating it. It's just in memory that this runs in. Then it's going to take this, it's going to drop it in here. Because we don't know, right? This could be all the way up to 1,000. and we want to check to see if there's duplicates. That's why I put that extra 5 there. So then if we go like this, there you go. Found a duplicate pair of 5. Found a duplicate 5. You saw that? So the outer loop runs a number of time, right? With the end time. That's what end time is. And the inner time runs also end time for each of those end outer iteration. So the total number of operations is approximately n times n equals n squared 2. So that's why it's O n squared 2. Now there is pattern. Therefore, there is pattern regardless of the language. PHP, what is it? Python, Java, not JavaScript. But I guess we could apply for that too. It's classified as an O. This guy right here. Get rid of this. Classifies this. And so I guess the key point is that, let's break this down. So while nested loops are the prime example of where O n squared 2 comes from, or square, not all O's and square algorithm uses the nested loops. Not all nested loops are O and 2. Anyway, for typical cases in PHP and elsewhere, pair loop of loops iterating over the full input sizes in the O n square. Now let's go to the linked list. So if we go to the linked list, oh boy. You know something, guys? How about if we, because right now I cannot breathe. Breathing through my nose, I can't do the, so what I like to do is pick this up later or tomorrow on another video. Let me see if I can. Let's see. What this do? Let's just do. I didn't want to go off because what time did I start running this thing? This thing is like. Listen, the linked list is like a sequential data structure, right? Remember that we showed you where each element called a node, remember that? It was called a node, contains data and a reference that points to the other node, like in the sequence. Like for example, a linked list representing, let's say, a number 10, 20, 30 will look like, 10, 20, 30. So the first node holds the data 10, it points to the node 20, and then the second node holds the 20, points to the 30, and then of course the 30 holds, it points to null if you stop there, indicating that the end of the list. So the web browser's history is like another example. You know how you visit, you look up the website, you hit a link, and then that page came up, and you hit another link, and that page came up, and then you hit another link, and that's what that is. So when you hit the back button, it's going to the one previous and the one next previous, is because they're all pointing to whichever. So if you go back again, the 10, let's say the first link will direct you to the second one, and then of course as a pointer to the third one. That's how that works. So in PHP, you create a node by just defining the classes to hold the data. So I think is this working here? Let me see. Okay, let's see. No, because I'm in the wrong place. Where is it? Where is that word error? Oh, I erased it. Hold on, right here. There were 50. You do this, you do that, you check. And that gave me that. Why is it a problem? Oh, that is what we checked. Okay, it has checks for the duplicate. So let's say we do that. That's not the one. Sorry, I just for some reason got myself confused there for a second. So if I go like this, right? We could say we could define the node class. We could say class node. I think I show you this with the void public data. Then you say public. That would be next. I don't know what I want to do here. How about we do the constructor? We'll make it public. There we go. Sorry guys, that looks gross. We're gonna say the function, and that will be 1, 2. Then we're gonna say caps constructor. I can't believe it. I'm leaking. Oh man. Data. And then we're gonna say right here. What is it? This. Remember, because this we're talking about the same class. We're gonna say data because you're looking at your property right up there. And we're gonna say that data like this. And then we're gonna say $this. That's the same thing. And then we're gonna say x. And then we're gonna say equal to null. That initializes the next pointer to null. That's what that is. Okay. Let's see. Thank you guys for pointing that out. So then what you want to do is we're going to create an instance of that node, right, of this class. That's when you create the new node. And that's going to be equals to new, but when I use the word new, that means you're going to create an object. So then you're going to say ODE 42, up. Now this guy right here now holds 42, the number 42. And it's the next pointer is null. So what you do is you say, okay, echo, let's see, new node data. New node. Sorry guys, I'm trying to clean my nose here. That's me spitting into paper. Alright, so then when you do this, then you know, right, that would be the data. So we're going to say data. Okay, let's see. Okay, let's just take a quick look for a second, man. I'm going to take this, put it at the bottom. We don't really need all this. Let me see. We create the node that the next construct the data. No data. Oh, new node 42. That holds it. New node equals data. And then you hit this. And there you go. New node data 42. where we add this? I guess before I go, I guess I'll come back to it anyway, because what I wanted to say is that because we're going to use arrays, right? Now you could create an assigned value to an array, right? You will see this all, forget about it. We've been doing this a lot, right? So let's say we go like to fruit, right? You go like this. This is another way of doing it, by the way. You say apple, remember that one? Then we did that reminds me, I like a banana, but it have to be cool with these carbs. And then you have your cherry. You know, I haven't eaten a cherry pie in a long time, right? This will still be, if you want this, like right here, look, like this. That's an O1. Real quick, happens fast. And in the associated array, it's the same idea. So if I did, hold on, let's see if this runs. What should we do with it? I mean, we got. Let's see. How do we do? We just do this. How about that? Fruit. Oh shit. Sorry. That should not take it long. And there you go. You got apple, cherry, or whatever that is. Associated array is more like, how about we do this? Look. Associated array. So let's say we do, let's say we say $age. Let's break it down like, oops. You know, you could do this too, by the way. You could say Peter. Oh, Peter! He's 35 years old. And you have Ben. And he's 37 years old. And then you got your Joe. Yo. 43. Let's move this down. And of course, don't forget that you'll say my colon, because it's not JavaScript, so I was going to put it in for you. And then what we could do is we could say, what is that? How about we do this? We say echo. Oh boy, what was that? Huh. So we're going to say echo age, and then this. Now remember how we used to do 0, 1, 2? Right here, let's just do Joe. Yo, Joe. And plus, I can't be sitting for too long because of the prostate thing. Right, let's see if we can do this. 43 years old, Joe. Joe is 43 years old. See, 43 years old. And you can do this too. Look, check this out. You could say, I think you must see this before, right? You go like this, and then say, I don't know, red, sing, you know, colors, red. Then you could say colors, green. That reminds me, I gotta paint later. And then you got colors, but oh, wrong thing. and then you have your what should we use? Stank and blue. Don't get me wrong, I love blue. I love blue. But I like black. It's my favorite color. We could say echo pre. What is it? Then we could say. Come on. Then we could say. What is it? Print R. And this will be colors. Colors. Maybe color. And then let's close it up again with this. Let's see. There you go. Red, green, and blue. Isn't that great? It's great stuff, man. It's the same thing with the stack and stuff. We'll do that. We'll continue that on the next video. Okay, because right now I'm not supposed to be sitting for too long. First of all, my knee, and of course, you know, the prostate stuff, because I am remission, but it comes back. And I don't want it to come back too heavy. That's not good, you know. And I like you guys. I want to continue doing this. So I hope you understand what I'm talking about. We're going to be talking about the stack. We're going to use the remember the class called the SPL stack. To do that, we're going to do that. So we're going to do that in our next video. Okay, buddy? This is where we get to use the P, pop, push, and all that stuff. You know, the stack, the fundamental linear data structure. You know, last in, first out, remember LIFO, that kind of thing. We'll talk about that on the next one. Okay, buddy? So, thank you again. Please give me a thumbs up. Subscribe. And go to the next video that's coming up after this one, which will be 115M2. And then from there, we'll continue with the stack. What else we'll continue with? We'll continue with the tree. What else can we continue with? The queue. What will be the next one? Is there another one? Let me see. Let's go here. Oh, by the way, let me show you. Down to the flow. This is the thing here. Look, the data structure, right? We talked about the array data structure. I should have been showing you this. And how you go 0, 1, 2. So if you want this number, you gotta say 3, right? Then we talked about the stack, which that's what's coming up. And the stack is the same thing. First in, first last in, last out. And they look at this as the last and the first out, right? So, which is kind of weird, but it's how they look at it. And this is what it kind of looks. So if you do the push, it puts it in. If you do the top, it pops it out. Then this becomes the new top, right? Then you got your queue, the data structure queue. It's kind of like you got your front head, and then you got your back, tall and rear, like this, right? You dequeue, and then you queue. You send it right back. You put that dime right back into the back. Or you dequeue, you take out from the front. That will be your 2. See how that looks? Like that. And then the tree is like this. See the tree? So if you got level 0, 1, 2, and 3, and then that will be the parent of this child, but then this child's the parent of these childs here. And you got your siblings, right? The last node. And this is how you know. This is how you do things. And I'll show you later why we would use the tree, you know. Tree's fantastic. It's a data structure where each element is a node and the parent-child relationship is there, you know? Like the root one will be like the topmost node. What is it? The leaf that they always talk about, like the leaf will be the node with no children, the one that's by itself, which I don't see. Like this one right here. And then, of course, parent-child sibling, and then you got the siblings, which is these guys. But we will talk about that on the next one. Anyway, we reached the bar. Please give me a thumbs up, subscribe, give me a comment. Tell me what I'm doing wrong. Or if I'm doing something right and you're getting to understand what I'm talking about. Anyway, a good night.